Hello, I'm Arjun Verma, and this is the final Lab 5 for Physics 2211. So the purpose of this lab was to analyze the forces acting upon a hypnotist's swinging pocket watch to better understand the forces behind hypnosis. So the physics principles I utilized in this lab that I created were the perpendicular and parallel forces. So I showed the formulas on the right where F net is for parallel is equal to the derivative of the magnitude of momentum times the direction of momentum, whereas F net perpendicular is essentially the opposite, where it's the magnitude of momentum times the derivative of the position, and then Newton's second law, where F net is equal to dp over dt, and then the definition of velocity, which, I don't really have to show the formula for. So now getting to the data collection of the lab. So the basis of this lab was a hypnotist seen in the picture swinging a pocket watch back and forth, and I utilized Tracker to record the position and the timing of the watch. So as you can see on the X-plot, mass A's position clearly follows a sinusoidal wave where it kind of goes back and forth, and it models, almost perfectly motion moving back and forth with the parallel force acting in the direction of motion, the perpendicular force pulling it back towards his hand on the chain, and the net force being the chain itself. So my glow script model, I did this by recording I started the glow script model by recording the positions of the watch in large arrays, and the time skip or the change in time was recorded as well. That way I could utilize the velocity formula in order to calculate the velocity at each position. And sphere objects were used to visualize the center, so where his hand is holding on to the chain, and the pocket watch itself. And then after that, I utilized the definition of velocity alongside the position and time data to find the velocity of the watch at each time step. So that's that V final equals, the current position minus the previous position over delta t. And then I utilized Newton's second law to find F net. And I did that by, doing the change in momentum over the change in time. And then I utilized the parallel formula in order to find the magnitude of the parallel by, taking the derivative of the magnitude of the momentum change, or essentially, the final momentum magnitude minus the initial momentum magnitude over time. And I found p hat, so the direction of the change in momentum, and that effectively created the parallel portion of the force. And since parallel plus perpendicular equals net force, I was able to find the net force by subtracting the parallel force from the perpendicular force by subtracting the parallel force from the net force. And that's how I found the parallel and perpendicular forces. And I then utilized arrows in order to visualize them, so you could clearly see how these forces were acting on the pocket watch, and you could visualize the forces acting on the hypnotist pocket watch to better understand the hypnosis itself. So the results of the model can be seen on the right, where the black dot represents the point where the pocket watch is held, and the red dot represents the pocket watch, with the black arrow representing the perpendicular force pointing towards, pointing orthogonal to the parallel force and pointing towards where it was being held. So that's where the perpendicular force was pulling it towards. And the parallel force pointing in the direction of motion. So as you can see right now, it's on the right, but the watch would be swinging to the left. And so it's pointing towards that direction as the watch swings to the left. And that's where the watch is accelerating at that moment in time. So it looks as if these are pointing in the correct directions, going to my analysis, where the parallel force is following the motion of the watch, and the perpendicular force is pointing towards the point where the pocket watch was held. So the parallel force caused the watch to accelerate in either direction, either pushing it to the left to when it reached the axis, like the apex on the right, or pushing it to the right after it reached the apex on the left. And the perpendicular force, not necessarily pulling it towards the center, but kind of keeping it in place with the force acting towards the center. So I guess it could be seen as pulling it towards the center. But yeah, with the perpendicular force kind of holding it in place towards the center, and the parallel force causing it to swing back and forth. As you can see in this model, they're all pointing in the correct direction, which is the most important part of this analysis. So yeah, some conclusions is that there are multiple forces acting on the hypnotist pocket watch, and they both contribute to the hypnosis, with the perpendicular component of that net force keeping the watch in place and pulling it kind of towards the place where the chain is being held, and the parallel force making it move back and forth. Those are both portions of the net force, and those are both crucial to modeling the forces acting on the watch as it swings back and forth. And yeah, thank you so much. That's my Lab 5.